There are two exponent properties that you are going to use the most, and this is one of them. We call this property product of powers. Now, the rule tells me that when two powers with the same base are multiplied. So I'm looking at two powers with the same base. So for example, like x to the third times x to the fourth, right? I have two powers. They each have the same base. They're both x's, okay? And they're being multiplied together. So this is the type of situation I'm talking about. Now what the shortcut tells me is when two powers with the same base are multiplied, I'm going to add up those exponents. So the rule tells me that when two powers with the same base are multiplied, you add the exponent. So if I look down at this example, x to the third times x to the fourth, and I use my rule, okay, since they're being multiplied, I'm just going to add up the exponents. So 3 plus 4 would make x to the 7th. So I already know that that's going to be my answer, x to the 7th. But let's try and figure out why this makes sense, okay? Well, if I think about x to the third power, I know that what that actually means is x times x times x, okay? And then if I also think about x to the fourth power here, well, I know that that means x times x times x times x. And then if I look at this all together, well, I have x times itself 1, 2, 3, 4, 5, 6, 7 times. So if I were to write that as an exponent, it would be x to the 7th. So even though my rule allowed me to take this shortcut and get the answer right away, why it makes sense is shown over here. So let's look at some examples and use our shortcut now that we understand why it makes sense. Example number 1, I have x to the 9th power times x to the 3rd power. The first thing I have to check is that they have the same base. Well, this base is x, this base is x. Awesome, they have the same base. So now what I can do, according to my rule, is add up the exponent. So I'm going to take 9 plus 3. Well, my base is still going to be x. 9 plus 3, that is 12. And that problem is now simplified. If I look at question number 2, I have a to the 12th times a to the 8th. Let's make sure my bases are the same. Yep, they are both a. So I'm going to add up my exponents. 12 plus 8 would make a to the 20th power. Number 3, 2 to the 3rd power times 2 to the 5th power. Check my bases first. They're both 2's, so I'm going to add my exponents. So 3 plus 5 is going to give me 2 to the 8th power. Number 4, g to the 3rd times f to the 6th. Well, if I look at my bases, they were not the same. If my bases are not the same, I cannot use this rule. So my answer just stays g to the 3rd times f to the 6th. There's nothing I can do with that problem. Now looking at number 5, this looks a little bit more intense. I have x to the 2nd, y to the 4th, times x to the 3rd y. Now here's the cool thing. I can use this rule even though these are kind of out of order. First I'm going to focus on everything with the base of x. And I'm going to add those exponents together. So I have my x, 2 plus 3 is 5. And now I can do the same thing for my base of y. I'm going to add their exponents, okay? Look at this. If a y doesn't have an exponent, what exponent goes there? A 1. So if I were to add up these exponents, 4 plus 1 gives me 5. So I have y to the 5th power. So I was able to use my product of power rule as long as I kept what had the same base together. So I had to keep my x's together. And then I also had to keep my y's together. I couldn't mix x's and y's.